Welcome to the next in our series of word problems. This is called nested rectangles, an area problem. We've already done nested rectangles, a perimeter problem. In this particular problem, we are building a 40 by 15 foot swimming pool. The pool includes 618 square feet of decking at no extra charge. So when you buy the pool, you are allowed to put 618 square feet of decking somewhere, and it costs nothing in addition. You want to have a walkway on the right side and the bottom, and you want to have a patio area on the left side. You want the patio area to be twice as wide as the walkway. So I'm going to kind of roughly sketch that in. Here's a walkway on the right side, a walkway across the bottom, and a wider patio area along the right side, which is going to be twice as long as the walkway. So that's basically what you're trying to build. If you don't want to spend anything extra for decking, how wide will that walkway be? Okay, let's let x be the width of the walkway. And the walkway is here. And so if that's going to be of width x, I'm going to put an x here and an x here for the walkway. And if the patio is going to be twice as wide as the walkway, I'm going to put a 2x here. And I built a pool, and it was adjacent to an easement, and I had so many free square feet, and I did something just about like this on my pool. Now the question is, what is the width of the walkway and the width of the patio? Well, clearly if I find the width of the walkway, I've got this problem solved, because I just double that, and that's the width of the patio. So what we're going to need now is we're going to need some dimensions on that big rectangle. Its length goes all the way from here to here. Don't need any dimensions on the small rectangle. The small rectangle is 40 by 15, but we need dimensions on the big one. Well, if you go from here to here, that's 2x, and if you go from here to here, that's 40 more, and if you go from here to here, that's another x. So the overall length of the big rectangle is 3x plus 40. So I'll say then 3x plus 40 is the length of the big rectangle. Now what about the width of the big rectangle? Well, that's going to run from here down to here. And it's 15 from here to here. And it's x from here to here. So this is going to be 15 plus x. Well, that didn't fit in there very well, so let me try to squeeze it in better. X plus 15. I hope that shows up on the final drawing, but the width of the rectangle is x plus 15, and you can see it from the drawing. Anytime in a math problem that you can draw something, you always draw it. Okay, let's go ahead and set this up. What about the area of that big rectangle? Well, it would be the length times the width. So the area of the big rectangle, and I'll just put area big, is equal to the length of the big rectangle, 3x plus 40, plus 40 times x plus 15. Now there's a second way we could write the area of the big rectangle. We know what the area of the pool is. The area of the pool is 40 by 15, which is 600 feet. And we also know the area of the decking. The area of the decking is 618 square feet. That's given to us in the problem. So that means, since the big rectangle is composed only of the pool and the decking, that the area of the big rectangle, area big, has to be 600 plus 618, which is 1218 square feet. So what we have just managed to do is write the area of the big rectangle two ways. It's 1218 square feet, and it is this amount, the length times the width. So if we set those two equal, we have a setup equation. And they are equal. They're both the area of the big rectangle. So I set up 3x plus 40 times x plus 15 is equal to 1218 square feet. Well, let's go ahead and expand the left side. 3x squared plus 40x plus 45x plus 85x plus 600 is equal to 1218. Subtract 1218 from both sides. 3x squared plus 85x minus 618 is equal to 0, and you're now ready to use the quadratic formula. One neat way to do a quadratic formula, if you happen to have a graphing calculator, you could do it this way. Try programming this onto the home screen of the calculator. Put 3 into the location A. You do that using the store key. You'll get that right facing arrow if you hit the store key, which is down on the bottom left of your calculator buttons, and then print a colon there, which tells you that one step has been completed. Then take 85 and store that into the location called B, which you'll print using the alpha key. And then take the number negative 618 and store that into a location called C on your calculator. And now we'll set up the quadratic formula. But before we do that, we'll set up the discriminant. I'll write that b squared minus 4ac will store into D for discriminant and put a colon there. And then to evaluate the quadratic formula, you'll just write negative sign. Now that's different than a minus sign, so be careful if you're using a graphing calculator. The negative sign is at the bottom of your list of buttons. The minus sign is on the right side of your list of buttons. So put negative sign B plus the square root of D, and then put that in a bracket, because that's going to be your numerator, and then for your denominator put open 2a close and hit another colon. A colon is second period. You hit your second key in the period, which is down at the bottom of your list of keys, and that'll give you a colon, and then that will give you your answer, and the answer in this particular problem is 6. That is, if you use the quadratic formula on there, you'll come up with the answers 6 and another answer that makes no sense. So the final answer to the problem is the walkway has width 6 and the patio has width 12. And if the problem's done in meters, that's 6 meters and 12 meters. If the problem is done in feet, that's 6 feet and 12 feet, etc. And that concludes our problem.